Hey, what's going on everybody? It is your boy Jay Bailey here, and I'm back with yet another video. And before I get started, I just want to say thank God it is Friday. I've had a long week, I'm telling you. It's been an adventure to say the least, but glad it's finally over and I get to come and hang out with you all, show you guys a nice reverse engineering challenge, and I hope you guys enjoy this one because I certainly did enjoy making it. And so let's go ahead and get started. So we see this is going to be the binary that we're working with today, and we notice the author here, he likes to put his name in the binaries, and this is the same guy who tried to trick us last time and throw us down some rabbit holes, and he got us with one of them, but for some of them he didn't really fool us. But so hopefully he doesn't try to do anything too crazy this time. We'll find out. So let's get started with opening our notes.txt and sudo.c and %. And then we're going to move that to the side, and we're working with ZED frequency. And all right, so let's just go ahead and run file. Oops, not IFLE, but file. And it looks pretty standard. We see that it's not stripped here, which is something we always like to see. And if everything else looks good, so let's just go ahead and look at the symbols in here. And we see that he's calling fgetC and fopen, so obviously he's going to be opening up some file that we give him. And we see down here he's doing a string comparison, so maybe what's in the file he's going to compare with some string, who knows. But let's go ahead and run strings and see what else we can find in here. And so we see something pretty interesting here. We see the success message is you succeed, and we see our failed message is you failed with 2 exclamation points. Man, that's harsh, Zed. Come on. 2 exclamations? I'm just messing. All right, and so we see here this generated key here. So this is either the key that we should generate, or maybe it's the actual key that we should give it. We don't really know yet. And the only way to find out is to actually test it out. So I'm gonna try everything kind of guy. This most likely won't work, but like I said, I just want to try it just to see if it's gonna work. You never know. Of course it didn't. It's never that easy, right? But that's okay. So let's note down what we see here, and we see that when we gave this as input, we received or we generated all zeros for the key. So I guess we got to figure out how do we get this as the key. That's what we need to find out. And let's go ahead and open this up in IDA Pro. I'm gonna go ahead, okay there. Yep, .bin and this guy. And I'm going to move this to the side and bring up our sudo C here. All right, and so as we discussed in the past, this variable here, var b4, is going to be our argc, and hit enter twice. And then this guy here is going to be our argv, and this here is just going to be, it's just going to store our stack cookie here. So we're just going to go ahead and rename this to stack cookie. Man, I could use a cookie right now. Couldn't you? A nice chocolate chip with some milk. All right, let me stop. And then we see it compares argc with 1, and if it's greater than that, you see that we're going to continue down here and do some code. So that looks like it's argc less than 2. Then we do I'm just going to say print usage and exit. Oops, didn't want to do that. All right, so I'm going to come down here, and we see we put argv into rex, and then we add 8 to that. So that's pretty much getting argv sub 1. And then you see here, this is kind of like dereferencing. So if you can imagine so right now rax holds the address of argv sub 1. Now it's getting the actual content that's in there. So that's why it's in square brackets there. So it's storing that to rax. And so now it's going to get the modes here, load that into RSI. And we even see the mode here, it says it's RT, which is awesome. And then it also tells you here that see it's the actual file name that's being stored into RDI, and then you see it's going to call fopen, and we see the stream variable here is stored to the output of that. So I'm just going to rename this to fp just because I like that better. So that's pretty much like this: fopen argv sub 1, and then RT. And then let's see what happens next. So you see here, this 0 is going to get stored to var b0. And if you look down here, we see that it's going to get used in a loop. So we're just going to go ahead and say I equals to 0. And it jumps down to 8FC, which compares that to hex 19. So while I is less than or equal to hex 19, we're going to do some things. And excuse, if you can hear that nonsense in the background, please excuse that. I lay right next to the highway. And we're gonna go ahead and rename this to I in here. And this loop is doing something very simple. All it's doing here is this, we see this in the array here that we haven't seen before, but it's just assigning 0 to each value, each element in this array. So this looks like, I'm just gonna call this array all 0 sub I, and I'm gonna assign that to 0, just like that. That's all it's doing. And I'm gonna go ahead and rename this here, array all 0. And let's see, so after that executes, we come down, let me keep scrolling here, not that far. All right, so now we're here. And we see we load up our file pointer into rex, and then we put that into RDI, and we call fgetC, and the result of that is stored into this I variable. And I don't like that I can't actually rename this to something else, but I mean, I guess that's all right. So what that looks like here, I'm just gonna say while 1, and I'm gonna do I equals to fgetC, and then put our file pointer in there. And then what do we do next? So we compare I to -1 here. So if I equals to -1, then we break. All right, and so then we get into something that is always kind of tricky for me when I first see it, and I hope I can explain this plain as well. So first we have, it compares I to hex 60, and you see it jumps to this location 956, and it does some other stuff here. And you see also it compares I to hex 7A, and also it jumps down here as well. But we really only need to check this one or this one to get to here, right? Otherwise it'll run this code. Oops, it'll run this code down here. And I just said, I kind of just said it myself that so we check if it's less than or equal to 60, or if it's greater than hex 7A, then we'll jump down here. Okay, so we have if I is less than or equal to hex 60, or I is greater than hex 7A, we're going to do stuff. And let's see what that's, oops, stuff. We need a vowel there, Josh, come on. And let's see, so then we compare I to hex 40, and if it's less than or equal to that, you see we jump back to the beginning of the loop. But you see there's some code down here, right? And this is, we obviously, when we want to execute this code down here. And so how do we do that? So then we have to, so I has to be actually greater than hex 40, so that way we can do this comparison. We compare this here. And again, if it's greater than hex 5A, we'll jump again to the beginning of the loop. So similarly, in order to execute this code down here, we have to flip this one again. So if it's less than or equal to hex 5A, we come down here. And so what that looks like is going to be if I is greater than hex 40 and I is less than or equal to hex 5A. That's the only way we're going to get down here if both of these conditions are true, right? And let's see what it's doing. So we assign EAX to I, right here. And let's just assume that we got, since we got down here, let's just assume that we gave it a valid character that can actually get here. And we're going to say we gave it the value of capital D, which is hex 44. All right. And so then we see that we subtract EAX from hex 41. So we do EAX minus equals hex 41. And you can look at that as saying I minus 0 hex 41, right? Because EAX is equal to I. So you can pretty much, if you just substitute it out, we can just kind of look at it like this. Okay. And then similarly down here, we have RDX equals to EAX. So RDX equals EAX, which again is I minus 0 hex 41. Okay. And then right here, we see this is essentially going to be array all zeros sub rdx, and it's going to put that into edx. So edx equals array all zero sub rdx. But remember, rdx actually equals to eax, and eax equals to I minus 0 hex 41. Okay. Then what do? We do edx plus equals 1. All right. So again, if we substitute all this stuff out, it looks like this. Just like that. Oops. Actually, it would look like that, more accurate. Okay, my bad. And then finally we do array all 0 sub rax equals to edx. And again, we're going to substitute these things out. So rax is I minus hex 41, and edx is array all 0 sub I minus 0 hex 41 plus 1. All right, and so that's all this thing here is doing. So I'm just going to go ahead and delete all of this stuff here, because I think you can follow along now. And that's all it's doing here. And I'm just going to simplify this. I'm just going to say plus equals 1, just because I don't like to have all that nonsense there. That's all it's doing. All right. So then I think I mentioned earlier there's like an else statement here, right? So if it's not less than or equal to hex 60, but it's also not greater than hex 7a, right? It's going to come down here and do this else statement here. And you can see it does the exact same thing, except we're just subtracting hex 61 there. So I'm just going to rewrite this: array all 0 sub I minus hex 61 this time plus equals 1. That's all it's doing. And I guess as an explanation here, so this is going to be, if it's a uppercase letter, you can see that it's going to add 1 to this index here. Oops. To this index here. And if it's in lowercase letter, it'll add again 1 to that same index, right? So this is essentially counting the frequency of letters in our file that we give it. And what was this challenge called again? Oh, right, it's called frequency. And that's pretty much what all he's doing. So we're counting the frequency of these letters in our file that we provide the program. All right, so let's just continue. And you might actually already know what the solution is if you didn't figure it out yet. But let's continue really quickly, and let's run through what else it's doing. So then it prints out the generated key is, and then it sets this value here to 0, and you see this is going to be used in a loop here. So we're going to go ahead and rename this to j. And so we have j equals to 0 while j is less than or equal to hex 19. Then we do this loop here. And you see we do array all 0 sub j, right? And then we essentially just print out the value. So we do printf %d, and then we do array all 0 sub j. All right. And then what do we do next? So then again we get array all 0 again, and then we set that to eax. So eax equals array all 0 sub j, and then we add 30 to that. So eax plus equals 0 hex 30, and then we move that to edx equals to eax, and then we set eax back to j so we can index it again. And you see we have another new variable here, so I'm just going to call this new string here. And then we set the result of that. So right, so we do essentially new string sub j equals to edx, and edx actually equals to array all 0. If I just substitute all this out, sub j plus 0 hex 30, and that's all this loop here is going to do. And of course we have to j plus this guy. Oops, and I guess up here too we have to I plus this, right? Or making infinite loops here. Come on. And let's see, we delete that, and that looks good. And so then we come here. Let's see, after that executes, we just print out a new line, and then we're going to do our string comparison, right? So we load up our new string that we just created, and then we also load up this S2, which is our, looks like it's the key, right? And we compare the two. So we have if strcmp, and we have new string and S2. Oops, I'm just gonna say if there are equal, oops, I have to do 0. And if they're equal, then we do success, we win. If not, then we lose. How sad. And so if you might be able to see what's going on here, and if you can't, let me just show you really quickly. So I mentioned that it's going to print out, or is this loop here is going to count the frequency of letters in our array here, right? So if it's going to count how many A's there are, how many B's there are, how many C's, etc., etc. And this here is essentially just saying, it's just putting those frequencies into this new string right here. And it's adding hex 30 because hex 30 is going to be 0. And it's similarly kind of up here while we're subtracting hex 41 or hex 61. It's doing kind of the similar thing where if the frequency was 3, it'll be hex 33, which is in ASCII 3. So that's all that's doing here. And so if we come here, we paste this here. I'm going to paste, and I'm going to type out our alphabet here. So I'm going to A, B, C, D, E, F, G, H, I, J, K, L. H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABC. Okay, let me. Okay, so we have. So now I hope it's kind of clear what we have to do. We have to create a file that has 0 A's, 1 B, 2 C's, 3 D's, etc., etc. Right? So let's go ahead. Oops, dang it. All right, let's go ahead and just put this to the test. All right, I'm just going to show you really quickly. So I'm going to create a file. I'm going to have 3 A's, 2 A's, 3 B's, a J, and also going to have a lowercase j, just to show you that if it's uppercase or lowercase, it's still going to count towards J. I'm going to put that to a file and just look at that really quickly. All right, we're going to key file this, and you see we had 2 A's, 3 B's, and 2 J's. So now our assumption is correct, right? So let's go ahead and cat frequency. I've already done this for you all, and you see we have 1 B, 2 C's, etc., etc. And let's go ahead and run this with our binary, and yay, we got it, we succeeded. And yeah, that's pretty much it for this challenge. So that's a quick recap here. We solved this by looking at how they generate our key, and we figured out that they generate our key by counting the frequency of letters, alphabetic letters in our key file that we provided, and it compares it to this key here, and it wants us to have 0 A's, 1 B, 2 C's, etc., etc. If we create a file that has these frequencies of letters in there, we will eventually succeed. And yeah, so that's pretty much it for this challenge, everybody. If you like this video, you enjoyed this, you learned some new things, give me a like. I really appreciate that. If you have any questions that maybe I didn't address, or some just went completely over your head, do not hesitate to ask in the comment section below. I'm in there pretty frequently, so ask your questions. I will give you my best answer. Yeah, and if you have a challenge that you want me to try out next, go ahead and leave that in the comment section below. Can't guarantee it'll be my next video that I put out, but I guarantee that it will be on my radar, and I will work on it, and eventually I will solve it, and I will show you guys my solutions. And finally, if you enjoyed this video, right, and you will see more of this type of content, do not forget to subscribe and hit that bell icon so you're notified when new videos go live. I'll see you guys in the next one. Peace out.